Tapped service entrance cables can create a service panel, which necessitates a grounded neutral and a grounding electrode conductor bonded to the panel. According to the National Electrical Code, specifically Section 250.70 burn, the offset fitting should incorporate a grounding type locknut, given that it's considered service equipment. A lack of a grounding locknut can lead to straight current flowing back, potentially causing a shock hazard. The offset fitting itself could also create a pinch point, posing a risk of damage to the service entrance cables. The proper solution involves replacing the existing fuse panel with a new breaker panel equipped with spare breakers. This approach ensures a dedicated service panel with adequate grounding and protection, addressing both the safety concerns and code compliance issues. It is important to understand the specific requirements outlined in the National Electrical Code regarding service panels and grounding. The NEC provides detailed guidelines on how to properly ground electrical systems to minimize the risk of electrical shock and fire. Firstly, service panels must have a grounding electrode conductor connected to a suitable grounding electrode. This grounding electrode can be a ground rod, a ground plate, or of the metal frame of a building, depending on the specific circumstances and the requirements of the NEC. Secondly, the grounding electrode conductor must be sized appropriately based on the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. Thirdly, the neutral conductor in this service panel must be bonded to the panel enclosure. This bonding ensures that the panel enclosure is at the same electrical potential as the neutral conductor, minimizing the risk of electrical shock. Fourthly, all metallic components of the electrical system, such as conduit, boxes, and enclosures, must be properly grounded. This grounding helps to create a low impedance path for fault current, which helps to quickly trip over current protection devices such as circuit breakers and fuses, minimizing the risk of electrical shock and fire. The NEC also addresses the specific requirements for grounding locknuts. Grounding locknuts are designed to provide a secure electrical connection between the conduit and the enclosure, ensuring that the conduit is properly grounded. Grounding locknuts are typically required when the conduit is used as the grounding conductor. In the scenario described, the offset fitting should have a grounding type locknut to ensure that the conduit is properly grounded. Using a standard locknut in this application could create a high impedance connection, which could increase the risk of electrical shock. It is also important to consider the potential hazards associated with tapping off the main incoming lines. Tapping off the main incoming lines can create a situation where the overcurrent protection devices are not properly sized to protect the downstream circuits. This can increase the risk of overloading the circuits and causing a fire. In the scenario described, the 40 amp main breaker panel is tapped off of a 100 amp fuse panel. This means that the 40 amp breaker panel is protected by the 100 amp fuses in the main panel. If the 40 amp breaker panel is overloaded, the 100 amp fuses may not trip, which could cause the wiring in the 40 amp breaker panel to overheat and potentially cause a fire. For these reasons, it is generally recommended to avoid tapping off the main incoming lines whenever possible. Instead, it is usually better to replace the existing fuse panel with a new breaker panel with spare breakers. This approach provides a dedicated service panel with proper grounding and protection, ensuring that the electrical system is safe and compliant with the NEC. Replacing a fuse panel with a breaker panel can offer several advantages. Firstly, breaker panels are generally considered to be safer than fuse panels. Breakers are designed to trip automatically when a fault occurs, while fuses can sometimes fail to trip, which can increase the risk of electrical shock and fire. Secondly, breaker panels are more convenient than fuse panels. Breakers can be easily reset after they trip, while fuses must be replaced. Thirdly, breaker panels offer more flexibility than fuse panels. Breakers are available in a wide range of sizes, which allows you to easily customize the overcurrent protection for each circuit. When replacing a fuse panel with a breaker panel, it is important to follow all of the applicable requirements of the NEC. Firstly, the new breaker panel must be sized appropriately for the load that it will be serving. The NEC provides guidelines on how to calculate the load for different types of occupancies. Secondly, the new breaker panel must be properly grounded. This includes connecting a grounding electrode conductor to a suitable grounding electrode and bonding the neutral conductor to the panel enclosure. Thirdly, all of the wiring in the new breaker panel must be properly sized and installed. This includes using the correct type of wire for each circuit and ensuring that all connections are tight and secure. Finally, it is important to have a qualified electrician perform the work. A qualified electrician will be familiar with the requirements of the NEC and will be able to ensure that the installation is safe and compliant. Ignoring proper grounding techniques in code compliance can have serious consequences, including electrical shock, fire, and property damage. Therefore, it is essential to prioritize safety and adhere to all applicable codes and regulations when working with electrical systems. It is equally important to have any electrical work inspected by a qualified electrical inspector. An electrical inspector can verify that the work has been performed correctly and that the electrical system is safe and compliant with the applicable codes. In addition to the specific issues raised in the scenario, there are several other general safety precautions that should be followed when working with electrical systems. Firstly, always turn off the power before working on any electrical equipment. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the equipment. Secondly, use insulated tools when working with electrical equipment. Insulated tools will help to protect you from electrical shock. Thirdly, never work on electrical equipment when you are wet or standing in water. Water is a good conductor of electricity, which can increase the risk of electrical shock. Fourthly, be aware of your surroundings. Avoid touching any metal objects while working with electrical equipment, as this could create a path for electricity to flow through your body. Fifthly, if you are not comfortable working with electrical equipment, do not attempt to do so. Hire a qualified electrician to perform the work. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Also, it's worth noting that electrical codes and regulations can vary depending on the location. Therefore, it's important to consult with local authorities or a qualified electrician to ensure that all electrical work is performed in accordance with the applicable codes. Furthermore, regular maintenance and inspection of electrical systems can help to identify potential problems before they become serious hazards. This includes checking for loose connections, damaged wiring, and other signs of wear and tear. By addressing these issues promptly, you can help to prevent electrical shocks, fires, and other electrical hazards. Proper labeling of electrical panels and circuits is also crucial for safety and troubleshooting. Clearly labeling each circuit breaker or fuse with the corresponding circuit it controls can help to quickly identify and isolate problems when they arise. This can also prevent accidental disconnection of critical circuits during maintenance or repairs. In addition to the technical aspects of electrical safety, it's also important to educate yourself and others about the dangers of electricity. This includes teaching children about the importance of staying away from electrical equipment and outlets, and educating adults about the proper use of electrical appliances and tools. By promoting electrical safety awareness, we can help to prevent accidents and injuries. In conclusion, electrical safety is a critical concern that should be taken seriously. By following the guidelines and recommendations outlined in the NEC, adhering to local codes and regulations, and practicing safe work habits, you can significantly reduce the risk of electrical hazards. Remember, when in doubt, always consult with a qualified electrician. The original installation described was indeed non-compliant with NEC code and presented safety hazards. The recommended solution of replacing the fuse panel and tap service entrance cables with the new breaker panel is the correct approach to ensure a safe and code-compliant electrical system.